We are going to the moon, and this time we are going there to stay. That is the plan developed by the US government, NASA, and dozens of their international and commercial partners. And if they succeed, we will witness something far greater than simply landing humans on the moon. Landing is difficult, but it is far from the hardest challenge. We have done it before. What comes next, however, is an entirely new chapter. We need to build on the moon. We need to establish a permanent base, essentially a small city on another world. No one knows exactly how this will be accomplished, but we already have some remarkably practical and innovative ideas for living beyond Earth. First, it is worth discussing where this lunar base will be located. The moon is enormous, and all previous human landings took place roughly in the middle of the near side, on flat, safe terrain where maintaining direct radio contact with Earth was relatively easy. But that was the 1960s. This time, as we return to the moon, we are aiming for a much more intriguing destination, the South Pole. This region is covered with impact craters, mountain ridges, and ancient volcanic formations. Some valleys and craters remain in permanent shadow. Sunlight has not touched these surfaces for millions or even billions of years. They are believed to contain significant deposits of water ice, delivered long ago by asteroids and comets from the outer reaches of the solar system. NASA has identified 13 potential landing sites within the Artemis program. Most are small sunlit areas located on crater rims or low mountain peaks, surrounded by deep shadows and rugged terrain. It is an extraordinarily exciting region for scientific discovery, but also an extremely hazardous place for people who will need to live and work on the moon for weeks or even months at a time. As a result, we will need infrastructure unlike anything humanity has ever built before. Every fundamental element of a city on Earth will have to be recreated in one of the most hostile environments imaginable and with extremely limited resources. So, where do we begin? With roads. Yes, where we are headed, we genuinely need roads, landing pads, and other hardened surfaces on which to work and build. The primary problem that must be solved is dust. The lunar surface is covered by a relatively thin but incredibly light and fluffy layer of extremely fine dust. Every grain of this lunar sand is sharp and abrasive, like tiny shards of glass. During the Apollo missions, this dust was known to cut through the outer layers of spacesuits and leave scratches on astronauts' helmet visors. Even worse, the dust is highly adhesive. Its accumulation on the lunar rover contributed to overheating because it clogged the radiator. The problem is that, without an atmosphere and under very low gravity, disturbed dust can travel great distances. When Apollo 12 landed on the moon, the astronauts attempted to touch down as close as possible to the Surveyor 3 probe, which had landed there several years earlier. NASA wanted the astronauts to examine the condition of the spacecraft. They discovered that even though Apollo had landed about 180 meters away, Surveyor had effectively been blasted by dust kicked up by the landing module's engines. Therefore, if we intend to build a lunar base where people will constantly be landing, taking off, driving vehicles, and moving around on foot, we must do everything possible to remove dust from our daily lives. That means roads, landing pads, and hardened surfaces around the base camp. A quick and simple short-term solution may come in the form of something nicknamed rhino snot. This is the joking term used by the US military for a special spray-on product that stabilizes dirt roads and helicopter landing zones in field conditions. It was widely used in Afghanistan, transforming loose desert sand into a hardened surface. The material proved particularly effective at reducing dust clouds during helicopter takeoffs and landings. It could serve as a temporary solution on the moon as well. However, it is far from ideal because all of the material would have to be transported from Earth, effectively contaminating the lunar environment with microplastics. A more sustainable and scalable solution for building a small city on the moon may be to melt the surface itself and turn it into solid glass. This is exactly what the European Space Agency is currently working on through an experiment called PAVER. Scientists are using simulated lunar dust and a powerful laser to test a technology that transforms it into a hardened, glass-like surface. The idea actually dates back to 1933, when some people proposed building roads in Earth's deserts simply by melting sand. The logic is straightforward. Glass is essentially melted sand. For its time, the concept was completely impractical, but for a lunar base, it could prove to be one of the best options. We may not even need to transport a giant laser to the moon. Instead, a large lens could be used to concentrate sunlight. Specifically, this would involve a Fresnel lens, which focuses light through a series of specially designed grooves on a flat transparent surface, eliminating the need for massive curved glass. A Fresnel lens suitable for this purpose would have a diameter of just under 2.5 meters. However, given the geography of the moon's south pole, where the sun remains low on the horizon and shadows are extremely long, lasers may still be necessary. In any case, the process will be slow. European researchers working on the PAVR experiment estimate that constructing a landing pad covering 100 square meters with a thickness of 2 centimeters would take approximately 115 days. That is about 100 times slower than building roads with conventional asphalt. It is a significant challenge, but on the moon, transportation will be essential. The primary vehicles will be pressurized rovers, such as those being developed by the Japan Aerospace Exploration Agency in partnership with Toyota. This vehicle is also known as the Lunar Cruiser. These rovers will allow us to travel between different parts of the base without constantly putting on and removing spacesuits. A person will move directly from a pressurized habitat into a pressurized rover, and from there into the next building. This is how we will explore the distant and untamed lunar landscape. The Lunar Cruiser is essentially a home on wheels for the moon. It is designed to support 2 astronauts on journeys lasting 30 days or more, and will be powered by a hydrogen fuel cell. But if a house on wheels is useful, where will we actually live? The answer depends on whether we are talking about the short term or the long term. A permanent lunar settlement will not be built overnight, and NASA has already designed our first lunar home. It is called the Foundation Surface Habitat. This 3-level structure combines a metal framework with an inflatable module and can support up to 4 people for approximately 1 month. In practice, however, only 2 astronauts will usually remain inside the habitat, while the other 2 are exploring the moon in a pressurized rover. The first level of the Foundation habitat is a metal structure with a diameter of 4 meters. It contains the airlock, spacesuits for extravehicular activities, and a scientific station for conducting geological experiments with lunar samples. Astronauts will climb a ladder to the second level, an inflatable module that expands to a diameter of 6.5 meters. This level will house hygiene and exercise facilities. It will also contain a biological laboratory where astronauts can study the effects of the lunar environment on plants and animals. The third level will serve as the crew's primary living area. It will include sleeping quarters, a medical station, a kitchen, and a computer workstation. It will also feature a human research laboratory, where the astronauts themselves will become test subjects in order to understand how long-term stays on the moon affect the human body. Once we move beyond the foundation phase, construction of permanent lunar structures will need to begin. These buildings must provide protection and long-term security. We will need to shield ourselves from dangerous cosmic radiation, reduce the effects of the extreme temperature swings between lunar day and night, and protect the settlement from meteorite impacts. To achieve this, we may have to return to the very roots of human architecture and start building with bricks. Just as scientists believe lunar soil can be melted to create glass roads, they also think that lunar dust can be baked into construction bricks. The idea is to use inflatable habitats or even metal structures, but cover them with a shell of brickwork. This would provide protection from radiation and micrometeorites, while also offering thermal insulation, making heating and cooling systems far more efficient. China has already begun testing its own lunar bricks. Their concept involves constructing an egg-shaped structure called the moonpot vessel. The building process would be carried out by robots using traditional Chinese bricklaying techniques combined with 3D printing technology, employing bricks made from lunar soil. In 2024, China launched an experiment to produce bricks from 5 different simulated lunar soil compositions and tested 3 separate methods of heating the material until it hardened into stone-like blocks. Then, in November, these bricks were delivered to the Tiangong space station, where they were placed on an external experimental platform. Over the next 3 years, the bricks will be exposed to the vacuum of space, cosmic radiation, and extreme temperature fluctuations to determine how well they withstand these harsh conditions. There is also a remarkably bold concept that combines glass melting with habitat construction in the form of a giant spherical structure on the Moon. It sounds incredible, but the American company Skyports has already received funding from NASA's Institute for Advanced Concepts to develop the idea. In essence, it is glassblowing on a massive scale. Lunar dust is heated until it becomes a molten mass, then inflated into a large sphere using compressed gas. Because the Moon has no atmosphere and only weak gravity, relatively little effort would be required, allowing such a structure to grow to enormous dimensions without collapsing under its own weight. For greater protection and insulation, multiple layers of glass could be created with air gaps between them, similar to a multi-pane window. It may not be the most practical solution, but it is certainly a fascinating one. None of these options, however, can function without a reliable power source. This raises an obvious question: where will that energy come from? The sun, of course. Most lunar missions to date have relied primarily on solar power, and for their purposes, it has been sufficient. But solar energy poses a major challenge on the Moon. Because the Moon rotates much more slowly than Earth, it experiences an extremely long day-night cycle, 2 weeks of sunlight followed by 2 weeks of darkness. For human missions, this was never a problem, because astronauts stayed on the surface for only 3 or 4 days at a time. For autonomous spacecraft and solar-powered rovers, however, the situation is critical. They can operate for only about 14 days before effectively freezing during the 2-week lunar night. In most cases, they never power up again once sunlight returns. Even when they do, they rarely function as effectively as before. Now, take another look at the map showing the 13 potential Artemis landing sites. Notice all those shadows. Most of these areas remain in permanent darkness and never receive direct sunlight. Yet those same shadowed regions are where we are most likely to find the ice needed to sustain life in a future lunar settlement. The solution seems obvious: switch to nuclear power. Nuclear energy in space is nothing new. China has operated a nuclear-powered rover on the far side of the Moon for several years. NASA has been using nuclear-powered rovers on Mars for more than a decade. Even the Voyager probes, launched in the 1970s, still rely on nuclear power. However, all of these applications are relatively small in scale. Their generators use heat produced by the natural decay of radioactive materials and convert it into only a few watts of electricity. That is sufficient for robots and scientific instruments, but scaling such systems up to provide power for an entire lunar base is simply not feasible. We need a full-scale nuclear power plant on the Moon, and NASA has been working on exactly that for several years. Their project is called Fission Surface Power. It uses the same nuclear fission process that serves as the foundation of nuclear power plants on Earth. Uranium fuel atoms are split apart, releasing enormous amounts of energy in the form of heat. In space, where there is no water to boil and drive a steam turbine, a Brayton converter can be used to convert heat directly into electricity. The technology is quite complex, but the important thing is that it works. One advantage of those permanently shadowed craters that never receive sunlight is that a nuclear reactor can be placed there without any risk of overheating. The challenge is that these reactors must be compact. NASA has specified that they should weigh no more than 6 metric tons and be roughly the size of a large automobile. For a nuclear power plant, that is incredibly small. For a space system, however, it is still quite substantial. Rolls-Royce is one of the leading companies in the field of space nuclear technology. Most people associate the company only with luxury automobiles, but Rolls-Royce has been building nuclear reactors for the British Navy's submarines for more than 60 years. Their experience in this field is extensive. Their current micro-reactor design is expected to generate between 50 and 100 kilowatts of electrical power. At the upper end of that range, it would be enough to power a small factory or several average-sized homes. In other words, a single reactor would be sufficient to begin operating a small lunar base. And if several of these units were connected together, They could provide enough energy for an entire lunar city. And there it is, our first outpost beyond Earth, a gateway to the solar system. If we can learn not only to survive on the moon, but also to grow, build, and expand there, we will unlock opportunities in space that could never be achieved from Earth alone. This is how we boldly venture where no one has gone before.